Okay, so good afternoon to everyone. Now, today we will start the discussion from the paging concept. So, this is the question, like this, the question comes that give the details of how paging is implemented in the hardware. So, how the paging is working, that working principle has to be said. Now, here you see, the first we will see the diagram. So here, this is our processor. This is the processor. This is a CPU. CPU will generate the logical address. So CPU will generate the logical address, and this logical address is basically what? This logical address is divided into two parts. Now, what are the two parts? The first part is the P, which you see. The P is basically the page number, and the second part is known as the page offset. So these are the two part, page number and offset. So CPU will do what? CPU will generate the logical address, and this is what this logical address will be divided into two parts. One is the page number, another one is the page offset. And this page number will be used as an index of the page table. So this page number will be what? This page number will be used as the index of the page table. So there will be a table, that is the page table. In that page table, the index will be is that the page number. This page number will be the index of that page table. And the offset will be what? This offset will go to there as the page table contents. So the page table contains what? This page table will contain the base address. This will contains the base address, and this base address will finally combined with the offset to define the physical memory address that is sent to the memory unit. So that means here first what will happen? This division, the logical address will be generated, and there we will divide the two parts, page number and offset. This page number will be the our index of the page table. So page table entries from there. What will happen? This F is what? This F is basically our base address of the page table, and this base address will be what? This base address will be combined with the our offset, and it will from the physical address. This physical address will go to the as the physical memory address, and it will go to the memory unit. So this is the basic thing of the paging. Now here what happens? The logical memory, the logical address, we will say that logical address is what? We have already said that there will be the page number and the offset. So like this, there will be the total our logical address will be like this. So page, then page number and offset will be there. So it will be like this. Now this will be go where? This will be go as the index of the page table entries. So you see this 0 is go here as the index of there. This is gone as the index of it. That means this is what? This is the our page number. So this page number will go as the index of the page table entries. So that's why this is what? This is the index of the page table. This is the index, and inside of this what? Inside of this the our address is present. This address, then it will be combined. This will be combined with the offset, and after combining that, it will create the physical address. And this physical address will be what? This physical address will be go to the memory unit. So this is how the working of our page table. Okay. Now the next question that may came is explaining what is the translation look aside buffer, or in short form we say it is the TLB buffer. So this is the name, translation look aside buffer. The abbreviation from is TLB. So it is the given that explain what is the TLB and give details of how it is implemented. Now how it will be implemented? Give the example of it. So basically, to increase the system performance, most systems employ a form of memory cache for page table entries. So to increase the system performance, so that means to increase our system performance, we basically use this. And most of the system employ this form of memory caching for the page table entries. And this arrangement we call as the translation look aside buffer. And the buffer that is implemented in very fast storage, and there will be holds a number of recently used page table entries. That means what will happen? Now CPU will do what? CPU will generate the logical address. This will be same. And it will be what? It will be divided into two parts, the page number and the, but here in this, it is displacement. So this page number in that time, when in the paging concept we have seen that page number is gone as the index in the page table entries. But here, as well as it is going as the index in the page table entries, it will also go as the index of the look aside buffer. So this is what, like this, there will be a look aside buffer. This will be a buffer present. And here also, this page number will go as the index. This page number will go as a index in this buffer also. And in the page table entry, it will also go as the index. So both of this, in this both, it will go as the index there, as a page index into this. So that means the required page which is we are searching, that will be searched inside this first, then it will be searched into the page table. The required page we are searching. If the page is found in this look aside buffer, if the required page which is the we are searching, that page it find in the look aside buffer, then we will call this as the TLB hit. That is why in the memory organization we have seen also that if we find, then we say that it has been occurred. Same as that, the required page which we are searching, that we found inside this look aside buffer, then we say that the hit has been occurred. But if the particular page we didn't find in the look aside buffer, and that particular page we find in the page table, then we call it as a TLB miss. Because in this buffer, if the page present, there will be the hit. But if not present here, but if it is present here, then it will be miss, and we call as the TLB miss. So if there will be these things, and it will be the with the displacement same as the base address. The base address will go, and this base address with the displacement or the frame number, it will be combined with the displacement, and it will be generate the physical address which will be to the memory unit. So this is what it is said, that the virtual address translation will first search in the buffer for the required table entry. If found, the real address can be found immediately. But if not found, then the normal accessing of the page table will proceed. So it is the implementation. Okay. So first searching will be there. If it is not found, then the searching will be as a normal what we have seen in the paging. Same as that, the searching will be there. Then if we find, it will from the physical address and it will go to the memory unit. Okay, clear till now?
Yes, sir.
Okay. So this is the TLB. Now we will discuss what are the some advantage and disadvantage of having unequal size partition in the fixed positioning scheme. Now, the first we will discuss the advantage. Now, this advantage is what? It minimizes the memory wastage within a partition. So it will do what? It will minimize the memory wastage. It will minimize the memory wastage within a partition. But the disadvantage is what? It may happen that some queues may be empty, whereas some of the queues are long. A preferable approach is to employ a single queue for all process. The all process which came, for that we will have to use the same queue, because if we different queues are present, then what will happen? Some queues may be empty, whereas some queues will be very long. So the preferable approach is to employ the single queue. So employ single queue for all the process. And the number of partitions, is what? That number of partitions should be predefined. That means before that it will be defined, and the limits of the total number of active process in the system. So the number of partitions is predefined, and the limit, the total number of active process in the system. Partition sizes are present and small jobs do not run efficiently. So this the problem happens, that partition size will be what? This will be present, and some small tasks which came do not run efficiently for this reason. So these are the disadvantage of it. Okay. So now we have already seen the advantage and disadvantage part. Now we will see the next question, that is from here it can came. What is thrashing? What is thrashing? And what is the effect of it on the page fault occurrence or the page fault frequency? Now, the page fault, we have seen that page fault means what? If the page we are searching, that is particularly the CPU wants that page, and that page CPU will do what? First go to the main memory to access it. So if the page is not found there, then what will happen? The miss will occur. Yes, it may happen that the page is present. The page is present in the system, but it is in the secondary memory. Or let's say CPU will first search in the cache. Our cache memory is there. So CPU will search first, because with the CPU chip, this cache memory is associated. That's why the cache memory we have seen has the access time very less. So that's why the speed is very high for the cache memory. We have seen when in the memory organization, hierarchical organization I have shown, in that time I have shown the pyramid. So in that pyramid, if you see that cache memory is what? It is in the upper side. That means the access time is very less for that. And the speed is much more, because it is directly associated with the CPU or the CPU chip. So that's why what will happen? So main page fault is what? Now CPU wants to access some page. That page is what? That page is not present in the cache. If it is not present, now see, that means what? Miss has been occurred. And our page is what? Our page is present in the, let's say it is present in the main memory. It is present in the main memory, but it is not present in the cache. So in this respective, we can say that the cache miss has been occurred, because that particular page which CPU wants, that particular page is not present in the cache memory now. So what we have to do? We have to move that page. The particular page CPU is searching, and this particular page is present in the main memory. So what we have to do? We have to move that particular page from main memory to our cache. So if we move there, then the CPU will access in the next time. and the cache hit will occur because the particular page which it is it is demanding, that particular page is present there. So this thing is what, this is the miss and hit concept. And that time, if miss is there, that means what? That means the page fault, we say as the page fault is occurred. So this is the thing. This is the thing of the concept of the page fault. So here it is saying that what is thrashing? Now, thrashing is basically what? It is a process. This thrashing is basically what? It is the process. And this process is what? If a process, let's say, because we have several processes that will be executed by the CPU. So one by one process will become. Now, a process is thrashing. That means we can say that the process is thrashing if it is spending more time of paging than the executing. That means paging means what? The particular logical address, page number and offset will be there, and that page number will be index of the page table. So that means the searching is going on in the page table. The searching of that particular page, that is going on the page table. But the problem is what? It is spending more time on that rather than the particular page. It will go and executing for that. It is not doing that purpose. It is spending more time on paging than the executing of that particular page. Then this high paging activity we called as thrashing. That means finding the page, in the page table. It is spending more time on that. On that event, it is spending more time rather than executing the particular page, finding that and executing that particular page. It is not doing that. It is spending more time of this paging. So this high paging activity we called as a thrashing. This particular thing we call as the thrashing. And it is what? It provides serious threat to the paging system. So the paging system, the process, the whole process, it provides serious threats to that. Okay. This is what? This is the thrashing concept. This is what? This is the thrashing concept. Now, that means thrashing has what? It has the high page fault ratio. It has high page fault ratio. Now, the simple thing is what? When there will be that more time consuming, it is really a basic example. If you see, if the page is not found, we are not finding that page, we are not able to found that page, then only, because if we able to found the page in page table, then there is no necessary to check each and every again and again. मतलब बेसिक जो चीज है, देखो कि हम लोगों को पेज नहीं मिल रहा है, तभी तो हम चेक के बाद चेक करने के लिए इतना टाइम वेस्ट कर रहे हैं। अगर मुझे पेज मिल ही जाते तो हम क्यों टाइम वेस्ट करेंगे पेज टेबल में। अगर मानो कि पेज टेबल जो है, पेज टेबल में मेरा जो पेज है वो मिल ही गया, बहुत इजीली मिल गया, तो मेरा तो टाइम वेस्टेज का तो कोई जरूरत ही नहीं है। नहीं मिल रहा है इसलिए तो टाइम वेस्टेज मेरा हो रहा है। हम क्या है, फर्स्ट लोकेशन में देखे पेज नहीं मिला, नेक्स्ट इंडेक्स में देखे पेज नहीं मिला, थर्ड इंडेक्स में देखे पेज नहीं मिला, तो हम एक बाय एक इंडेक्स को चेक करते करते जा रहे हैं, इसलिए तो क्या है, मेरा टाइम वेस्टेज हो रहा है। अगर उसके साथ हम कंपेयर करें कि मानो कि जो पेज हम ढूंढ रहे हैं वो सेकंड लोकेशन में है, तो हमको तो क्या है, एक बार हम चेक किए मिला नहीं, सेकंड बार चेक किए मिल गया, तो इसमें तो मेरा टाइम वेस्टेज का तो कोई ये नहीं है। तो नहीं मिल रहा है इसलिए मेरा टाइम वेस्टेज हो रहा है। सो थ्रैशिंग हैज द हाई पेज फॉल्ट रेट। तो इसीलिए क्या है, पेज फॉल्ट का रेट जो है थ्रैशिंग का वो हाई है, क्योंकि पेज फॉल्ट कब होता है, कि जब मुझे नहीं मिलता है। ठीक है, कॉन्सेप्ट क्लियर कर पाए, समझ में आया?
यस
समझ
सर।
में आया सबको? ओके, जहां समझ में नहीं आएगा बोलना, ठीक है? देन when it is too high, the process needs more frames. Now if the page fault is too low, then the process may have too many frames. अगर मेरा पेज फॉल्ट जो है वो बहुत लो है, पेज फॉल्ट जो हो रहा है वो बहुत लो है, मतलब मैक्सिमम जो पेज हम ढूंढ रहा है वो पेज मेरा पेज टेबल में ऑलरेडी प्रेजेंट है, इसीलिए क्या है कि मेरा पेज को लाने का जरूरत नहीं हो रहा है। हम जो पेज ढूंढ रहे हैं वो सभी पेज मेरा क्या है, मिल रहा है, इसके अंदर मेरा पेज टेबल के अंदर मिल रहा है। तो इसीलिए क्या है, इसीलिए हम कह सकते हैं कि इफ द पेज फॉल्ट इज टू लो, then the process have too many frames. That means the searching which we are searching, that is particularly all the things are present in there. That's why what, too many frames are present, we can say. But if the actual page fault rate exceeds, that means the upper limit, we allocate the process to the another frame. And if the page fault rate falls below the lower limit, if the page fault rate falls below the lower limit, we remove the frame from the process. So thus we can directly measure and control the page fault to prevent the thrashing. तो मतलब मुझे क्या करना है, बेसिकली अगर देखा जाए तो मुझे बैलेंस करना है। हम ये भी नहीं करेंगे कि जितना पेज जो मैक्सिमम पेज है वो मैक्सिमम पेज अगर मुझे मिल गया, सभी पेज मुझे मिल जा रहा है, तब पेज फॉल्ट कम होगा, एकदम लो हो जाएगा, क्योंकि ऑलरेडी मेरा प्रेजेंट है तो फॉल्ट का तो कोई नहीं है। ये भी हम लोग नहीं चाहते हैं, ये भी नहीं हो, और ऐसे भी ना हो कि मेरा जो पेज फॉल्ट है वो बहुत एक्सीड कर गया, कि जो पेज जो ढूंढ रहा है कोई भी पेज मेरा नहीं है पेज टेबल में, तो पेज फॉल्ट का रेट बढ़ जाएगा। तो हमको क्या है, एक बैलेंस करना है कि जो हमको मानो कि 14 pages are required, let's say as an example 14 pages are required, that inside that 14 pages 7 or 8 pages can be present in the our page table, and another 8 or 7 pages can present in the our main memory. So if necessary, then we will brought it into the our page table. So we have to balance that so that the page fault ratio cannot, sometime it cannot be so low, or sometime it cannot just exceeds. This problem should have to keep in mind. So thus we can directly measure and control the page fault to prevent this thrashing condition. Thrashing condition happens when the page fault is what? The page fault is high. When the page fault is high, then the thrashing condition happens. So these things we should have to do. Now, the next question that came is, what is overlays? What is overlays? Now, overlays is what? It is the essence of overlaying, that the object program is constructed as a number of separate modules. It is the object programming that is constructed as the number of separate modules, and it is called as the overlays, which can be loaded individually and selectively into the some area of memory. So it can be loaded, these programs, which this object program that is constructed, the separate modules that we called as the overlays. This overlays will be loaded individually. That means we will create what? The object program that is constructed, number of separate modules, and we call that as overlays. So separate modules will be created. The object program will be constructed as number of separate modules. and it will be what? It will be loaded individually. We can load this as individually or selectively, that this we want, that we do not. We can this type also, we can load that, or individually one by one we can also do that, storing that into the some area of memory. In operating system, an overlay is called a process. It is what? In operating system we called it as the overlay is a process that requires itself with the code of another program. It is what? It is basically a process that do what? That replaces itself. That means replaces its own with the code of another program. With the code of another program is there, with that code it replaces. This we called as what? This we called as the overlay. Overlay we call this. Okay. And the last thing that is what we will discuss in this concept, that is what are the advantage, what are some advantage over the segmentation over paging. What are the advantage of using the segmentation of paging over the paging? Now advantage is what? For segmentation, external fragmentation is eliminated. External fragmentation is what? External fragmentation is eliminated. So external fragmentation already discussed, that if external fragmentation occurs when that we have the available memory. In this we have the available memory to service any request to, so that there will the block will go, so there will be the available memory present to service any request. But we are not able to do that because this available memory is what? This available memory is divided into block of small available places. That means this total available memory is what? It is divided into small memories. So that's why what happened, that we cannot, because it is, if we combine these small blocks, all small blocks of available memory, then there will be the large block present, and we can service the request to give the resource. But we are not able to do that because this large block of available memory is divided into smaller blocks of available memory, so that when this request came, we cannot be able to produce that. This is the, that's why the external fragmentation happens. So this external fragmentation is what? That external fragmentation is eliminated there. And the allocation and the deallocation of the fixed size units such as pages is easier. In the case of segmentation, the allocation or reallocation of the fixed size units such as pages is easier in the segmentation, and can share code and data with other registers tightly, so that only the desired portions are shared. That means the particular portion that share the code and data with other register tightly. That means the particular portion or the desired portion which is necessary, we can able to share. This is the advantage of using the segmentation over paging, and can associate protection with critical segments without protecting the other items. So here associate protection, the protection is associated with critical segments. So some critical segments will be there, and without protecting the other items. Without protecting the other items, we can associate protection with the critical segments. So that's why it is said that can associate protection with critical segments without protecting the other items. No necessary that whatever the segment which you want to give the protection, give the protection only for that, and for other you do not give the protection. Okay, so the last thing is under what circumstances the page fault occur. So it is already we have discussed that the page fault will occur when that if it is not found in our main memory, it is what if the processor needs to execute a page, if a processor needs to execute a page and that is not available, that is not available in the main memory. So what happens in the secondary memory, the page is available, so we have to do what, we have to move that page, we have to move that page from secondary to main memory, and the particular page which we are wanting or want to find, that particular page is not present there. So that means this is the circumstances with page fault occur, that we have to move that particular page from the our secondary memory to the main memory. This is what the page situation is, what this situation we say as the page fault occur. And when the page fault will happen, then the page replacement will be needed, and the replacement is what, the replacement is move that particular page from secondary memory to the main memory, so that CPU can easily access that. And why we, yes, you can say that why CPU can also access to the secondary memory from secondary memory also, then why we are saying to move that page in particularly in the main memory, then we can access, because if you remember that particular thing, that we as a user want what, our access time should be less, access time, because we as a user wants our access time should be less, and also the storage should be there. So for storage capacity, all the pages we loaded into the secondary memory, because secondary memory storage space is much more than the main memory. And also we want that our accessing will very fast, so that's why some pages we brought into the main memory, and the particular page we want to access, if this searching goes to the secondary memory, then the access time will be very maximized. But if we do it through the our main memory, then the access time will be less. So that's why what, but with all the pages we cannot store into the main memory because its space is less. So that's why this things, this process we do. Okay, it is clear.
Yes, sir.
Okay, so other everyone, it is clear.
Yes, sir.
Yes, sir.
Okay, so this is all about the memory management strategies. And totally, if I will say that we have completed all the portions in our computer architecture, organizational architecture concept, all the portions have been covered. And the first 2 3 things I have already said that it is a digital electronics part. So if I will able to take another class for you, then in that class I will discuss. But other than this, each and everything is completed, and I have this memory management strategies notes I will upload, you will find from there. And so this is what all about the computer organization and architecture. So in if the class is I can take the another class for you, then there are the mathematical problems, some mathematical problems we will discuss, and other than that the syllabus is fully covered for you. Okay, so thank you everyone. I am ending the session. Okay, thank you everyone. I am ending the session. I will
Thank
upload
you, sir.
this. Uh,